Good morning, Bears. It is a Tuesday. Corroborating evidence. What does corroborating mean? When we match things, information today from a video and a source. Now, you guys should all, gals and guys, should all have a source already in your slideshow. Let's go take a look. Here's Damien's slideshow, and look, he's done a great job. He has as his title slide a generating station with geothermal, cold water pumped down, warms up under the earth, comes back up into a generator or a combine, generates the energy, sends that energy into cities. I love it. Damien, good job. One of the key advantages is reliable and consistent. That was yesterday's Mandy. Let's see, he's got a bonus slide, just one more. No more memes. Now, I don't approve violence of any kind. And some people play slap games. This is funny, so I'm not saying you can't have it, but I'm just making sure everybody knows, no touchy. Always be nice unless you're in a boxing match or something that it calls for physical violence. We like to have our safe space, personal bubbles, but it's still funny. All right, Damien, and Damien's got his title there. So technically, if this is the title, this probably goes here. Remember, when I say top slide, best slide, that's top slide after the title. But now, this is what we really want to get to today. Look what we're learning about. We have thermal conductivity. Thermal conductivity is the ability of a material to conduct heat. This is what we've been talking about. In all our project, people had their picks: small tank, big tank, bring the heat up. Our main theme then was that a bigger mass is going to have more molecules, therefore more thermal energy, even if the heat or the temperature is lower. But when you heat something up, it will have more thermal energy for a time, and then it moves around. But the mass matters. So that's why if you're just going by that, you'd say the bigger tank. But they did not give us a lot of details. They didn't tell us where the water came from. They didn't tell us it was recycled. They didn't even show in their pictures how it came back into the building. And so we determined that there was a good argument to be made for both claim 1 and 2. But then now let's talk about that water's coming into the building. How is the heat from the water getting into the air? How is it? Is it through radiation? Is it through conduction? Is it through convection? Well, a lot of that has to do with conductivity. So conductivity is a value for thermal conductivity can be determined by measuring the rate at which heat can pass through a material. Thermal resistivity is the opposite of thermal conductivity. This means not conducting heat much. So, for example, we did use this in a sim a little bit. You're welcome to go back and play with it. There was wood, there was iron, I think there was cloth. For example, wool, clothes that are made out of wool, they keep heat in, which means they're not a good conductor of heat. Because if you have clothes and you want them to be warm, you don't want them to be a good conductor of heat, because guess what? They'll take the heat from your body, they will conduct it out into the air, and then you freeze. The one thing about wool is even when it's wet, it keeps its insulation, which means thermal resistivity. So it's insulate you. If we were in the classroom, and you guys can do this at home, you can do an experiment where you put ice into water, or maybe you put hot water in. You can do it cold water or hot water. We've done this in class a lot of times. You can create your own insulation. You can just wrap the cup in toilet paper. You could put the cup into sand. You could put the cup into a sock, and then have the other cup with nothing, and then measure the temperatures over time, and you could graph out, is it staying colder if you're doing ice, or is it losing its heat faster if you're doing boiling water? And there you can find out the insulation principles, the conductivity principles, and a lot of fun things. So feel free to look on YouTube, just type in heat conductivity or heat transfer experiments, you'll find a bunch. You'll get some clues in the slides. So in today's video, if they mention thermal conductivity at all, or materials, what we're going to do today is we're going to corroborate the evidence. So right now, if you want, over this next 5 minutes, you can go check your slides. If you have not created them yet, you need to go create them. Doesn't take that long. Just get a picture, at least a visual picture, and get the word I already put in there and some evidence. Because then as we watch the video, anytime we hear something that corroborates our slide, we're going to pause the video We're going to put a note here. And we're just going to put from video, so we know it's a different source. And then just what did you learn? How does it match this? So as we follow along in our lesson, remember those are directions, you're going along and you might see conduction. Once again, conduction is the transfer of thermal energy through direct contact between particles of a substance. So notice, conduction is the transfer of thermal direct contact. So look at this. Conduction is the metal gets warm here, the heat moves up the handle, touching the glove, and it will get hot. What about radiation? We're going to find that out in a minute. So when the video talks about conduction, what are we going to do? We're going to put a little text box and just match. Now, what's matching? It could be maybe they use a similar example. Maybe they use a different example of conduction. Maybe they do use different words. You can use your own words by describing the video. So when we get to conduction, we'll pause the video. We'll put a corroborating evidence for conduction. Then we will do the same for convection, and we will do the same for radiation. So before we do that, I'm going to give you about 5 to 6 minutes. This is for people that aren't caught up. Now, Damien is caught up. So what's he going to do in this 5 to 6 minutes? He is going to upgrade his concept slides by putting his own analysis. He could put real world example. So this is A level. While everybody else is catching up, you're going to put my life. And so this is another form of evidence, right? Something you've seen in your life. So what's your life example? What's an example in your life that shows you how radiation works? By reading the definition, by looking at the picture, you're going to do a My Life text box. So Damien, because he's going for an A, right now over this 5 minutes, can start doing his My Life slide. My Life text box, I'm sorry. So look at this, picture it. Where has this happened in my life? Now, it could be that tell a story about being at being at a campsite with a fire pit, and you remember the heat radiating off in your face. So that's a My Life based on this picture. So My Life is an anecdote from your life where you help remember what conduction, convection, radiation is. And let's just stick with those 3. If you want to do the other ones, you can. All right. My Life for A-level students. If you have not opened your slideshow, you go get going. Find a conduction, find a convection, find a radiation. All right, 5 minutes. Let's go. So now some of you have My Life slides. Some of you have pictures. Sadly, some of you probably have still not opened it or done any of the work. Well, for you people that have not done any of the work, you still have a chance because we're going to pause this video every few minutes. An 8-minute video on average. We're probably going to stop every 1 to 2 minutes and put our corroborating evidence where it goes. Now, when we do that, it only takes 2 minutes. I'm going to stop the video. You go in your slide. You make a text box. You write what you learned about the specific word. Some of you can do this as the video plays a little bit. Some of you can't. If you don't quite finish in the 2 minutes, you have enough written down to remember what you wrote, and you can come back and edit after. All right, so let's go watch the video. The video's heat transfer, 8-minute video, great video, but we're going to go click the link in YouTube so we watch it the appropriate way and give these people credit by giving them links. You can always like videos if you like it. It helps them. They help us. So let's support the cause. All right, let's go watch the video. I will pause it as we go. If you're in Zoom, you just do this on your own and finish up your slides. Okay, if you're in Zoom with me, we have gone through together this video. We should have a bunch of slides with a My Life, and then you should also have a My Life box, which don't forget, you can frame these boxes any way you want. It's kind of fun. And then you should also have a from video. So we basically are doing multiple sources here. We're learning from the picture, we're learning from the internet text, we're learning from the video, and we're learning from our own lives and experiences. Okay, so that's the goal today. So if you're watching this video at home, go back and watch this video, link in groups. Because, I know I pause it, I play the video, now we're back. So you're like, how did we get to this? Go watch this video and do everything I said. Look for evidence for every one of these slides, radiation, convection, and conduction for those, and maybe for conductor. We'll see how the video gives us evidence for this thermal conductivity. We're going to put notes. So my life box from video box, and you should have a good understanding of these concepts and ready for Wednesday, which acts like a Friday, because tomorrow, guess what? Last day of science, and then we'll dive into history on Thursday. Should I give you the advanced Friday? No, I think we'll do that together in class. All right, here we go. Have a great day, everybody. Watch the video back if you have any questions.